class 12 preparing for Keam exam. Welcome to Differential Equations one shot. So in today's class, I will help you revise entire chapter of differential equations with all the concepts, all the formulas, all the shortcut tips and tricks. We will also do previous year questions asked in Keam exam, and I will give you a mind map of the entire chapter for your final revision before your exam as well. Alright, so let's see what all topics we are going to cover today. So we'll learn about differential equation, order of differential equation and degree of differential equation. This is highly asked in every exam. Then general solution of differential equation, particular solution of differential equation, and the three main methods to find out the solution: variable separation method, homogeneous differential equation and linear differential equation. So if you are somebody who is preparing for Keam exam, then you should quickly subscribe to this channel. You will get maths, physics, chemistry lectures every day, and we are doing a crash course for revising all the chapters of class 11th and 12th, physics, chemistry and maths, just for you. Okay, so before your exam, the entire revision will be over, so don't go anywhere else. Just subscribe to this channel and stay tuned for more videos. Alright guys, so are you excited? Give me a high five quickly and let's revise differential equation. Okay, first, what is a differential equation? So basically, till now we have always seen an equation of maths. For example, we see equation like 2x plus 3y is equal to 4. This is what? This is an algebraic equation, right? Now, similarly, in this equation, if I involve a derivative of a dependent variable with respect to an independent variable, first order derivative, second order derivative, third order derivative, anything. If I just add a derivative, it becomes differential equation. So in this equation, if I write it as dy by dx plus 2x plus 3y is equal to 4. So just by adding this derivative, it became differential equation. Clear? So what is a differential equation? Now, whenever we write a differential equation, we have to involve a derivative. Derivative is basically differentiating the dependent variable with respect to independent variable, right? So we always have first order derivative, second. Matlab, if you differentiate it one time, if you differentiate it two times, if you differentiate it three times, and so on. So we can denote it in multiple ways. First method is, you can denote it like dy by dx can be written as y dash. So in the future, in the entire chapter or in your question paper, if you see y dash, single dash, so it means dy by dx. Okay, if you see y double dash, it means d square y by dx square. It is double derivative. Okay, similarly d cube y by dx cube will be triple dash. Now suppose if we want to denote d 14y by dx 14. So will I draw 14 dash 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14? That will be too long. So I'll not do that. I have another method. Another method is, you can simply write y dash as y1, y double dash as y2. So you can also write it in the subscript form. That is also allowed. Okay, so this is basically how we denote derivatives. I'm telling you this because in exam, if they write y dash, don't get confused that what is y dash. Is it a complement or what is it? Okay, chalo. Now, most important topic, it is asked every year in the question paper: order of a differential equation and degree of a differential equation. I am going to tell you multiple variety of examples so that you will never ever get confused in any question. Okay, so first of all, what is the order of the differential equation? It is basically the highest order derivative you have in the equation. For example, if your equation is, let us suppose, d square y by dx square minus 2 times of dy by dx is equal to 4y. So what is the highest order derivative? This is first order derivative. This is second order derivative. So which one is bigger? 2 is a bigger order derivative. So order of this equation is 2. Okay. Similarly, if you have an equation y3 square minus y2 plus 2 times of y3 is equal to 4y. Again, in this equation, what is the highest order derivative? Here you see 3, 2, 3. Which is the highest? 3 is the highest. So the order is basically 3. It is just the derivative that you have, whichever is the highest derivative. Okay. Now, what do we call as first order differential equation? So any differential equation which only has first order derivative, and second order derivative differential equation will be any equation that has second order derivative as well. For example, if your equation is dy by dx minus y is equal to 0, this is a first order differential equation. But if your question is d square y by dx square minus y is equal to 0, this is a second order differential equation. Simple. Okay. Now, the more important one is the degree of differential equation, because it is tougher to understand. Now, degree of a differential equation is defined as power of highest order derivative, given that your differential equation is in polynomial form. Now, what is polynomial form? Every derivative should have what? Should have whole number as power. Whole number as power. So for example, if your equation is d square y by dx square whole cube minus dy by dx plus 4 is equal to 0. So here the order of the differential equation is 2, because the highest order derivative is 2. But what is the power of d square y by dx square? What is the power of this term? 3. So your degree will be 3. Okay. Similarly, I said that the power should be a whole number. What does that mean? Suppose you have written d square y by dx square to the power 3 by 2 minus dy by dx to the plus 4 is equal to 0. What is the order of this equation? 2. But what is the degree of this equation? Will I write 3 by 2? No. It should be a whole number. It cannot be fraction. It cannot be decimal. It should be a whole number. Only then you can define the degree. But then how will you define degree for this equation? Let me show you some example. Example number 1. y2 to the power 3, y1 to the power 2. What is the order of this equation? 2, because highest order derivative is 2. What is the degree of this equation? 3, because power of highest order derivative is 3. Similarly, y1 minus sin x is 0. What is the order of this equation? 1. What is the degree of this equation? 1, because y1 power is 1. Now here, y2 to the power 2, y1 to the power 1 by 4. Is this a whole number? No, it is a fractional number. So I have to make this as a whole number. How can I make this as a whole number? Just I will write it as 2 times of y2 square is y1 to the power 1 by 4, and then I will apply power 4 on both the sides. So this will become 2 to the power 4 into y2 to the power 8, because 4 2s are 8, is equal to y1 to the power 1 by 4 into 4, 4 cancel. So this will become y1 to the power 1. Now, what is the order of this equation? It is 2, because highest order derivative is 2. What is the degree of this equation? 8, because the power has now become 8. So don't write the degree as 2. Degree will not be 2 unless you make this as a whole number. So degree will be 8. Okay. Some more interesting questions. Y3 to the power 2, Y3 to the power 3, Y to the power 1, Y2 to the power 2. So order is very simple. Order is 3 because highest order derivative is 3. But what about degree? You have 2 power. Here the power is 2, here the power is 3. So which one will you pick? You will pick the highest power. Don't add them, subtract them, multiply them. Just pick the highest power. So degree will be 3. Clear? Next, now this is very interesting question. Focus. Y2 to the power 1 cos of y1. So this equation is basically d square y by dx square minus cos of dy by dx. Now here the order will be 2 because the highest order derivative is 2, but the degree will be undefined. The answer is undefined. Why? Because this derivative is inside cos function. It is not having whole number as a power. It is not a polynomial function. This is a trigonometric function. It's not a polynomial function. So the degree will be undefined. So I have shown you every type of example that can be asked in your question. So you will not get confused anywhere. Now let us practice some questions also to give you more clarity. Before that, one very important point. Now, whenever we are talking about order and degree of a differential equation, always remember order and degree is a positive integer. It is never a negative integer. Secondly, whenever we are talking about order of a differential equation or degree of a differential equation, it can only be expressed if the equation is in polynomial form. Otherwise, it is undefined. Okay. So, let's do one question. What is the degree of this differential equation? You see, power is a fraction. Fraction is not allowed. So, what should we do? Let's remove fraction. How can we do that? 1 plus dy by dx whole square to the power 3 by 2 is d square y by dx square. Okay. Now, what can I do is, I can simply put square and square on both the sides. Why am I squaring both the sides? Because this 2 will get cancelled, right? So this will become 1 plus dy by dx whole square to the power of 3 by 2 into 2 is equal to d square y by dx square whole to the power 2. So here 2 gets cancelled. Now the power is a whole number. So this becomes defined 1 plus dy by dx whole square to the power 3 is equal to d square y by dx square to the power 2. So now what is the degree of this differential equation? Since d square y by dx square is having power 2, so this is the degree of the differential equation because power of highest order derivative. Simple. Okay. Another interesting question. What is the order and degree of the differential equation? So when we look at the equation, we see here the power is 1, the power is 2. But here it is a logarithmic function. Inside logarithmic function, you have a derivative. Is this polynomial function? This is not polynomial function. This is a log function. So it is not allowed, not defined. So here order is defined. Order is 2 because highest order derivative is 2. But degree will be undefined. Undefined because it is not a polynomial function. Directly you can mark the answer. Okay, so I hope you have understood order and degree. It is asked every time, every year in the exam. So do consider it is important. Okay, next is, always they will ask you 3-4 questions of finding solution of differential equation. It is very easy. So just learn properly all the methods I'm going to teach and you will be able to solve any question. Okay. First question. General solution of nth order of a differential. Basically first you have to understand what is a general solution and particular solution. Then we will learn different methods of doing it. Okay. Now what is a general solution? Suppose you have a normal equation like 2x plus 3y is equal to 5. Now, if I ask you, what is the solution of this equation? So, you will say, if I put x is equal to 1, y is equal to 1, left hand side becomes equal to right hand side. Therefore, x is equal to 1, y is equal to 1 is solution of equation, right? Now, similarly, for a differential equation, now if I have a differential equation like let's say dy by dx minus y is equal to 0. This is a differential equation. So, there will be a function for which LHS becomes equal to RHS. That function will be called as solution of the equation. Okay. Now, I know you might not have understood anything, but let's take an example to understand that. Suppose I tell you, I have a differential equation y plus y double dash equals to 0. I want you to check, is this the solution of the differential equation? Let's see. How can we tell that this is a solution of the differential equation? First of all, we have to find out double order derivative. So, if here y is this, then y dash will be a into dy by dx of sine. What is sine x derivative? Minus cos x. So, it will be minus cos x plus b. This is y dash. Again divide it. Y double dash. Again derive it. So, it will be minus a into dy by dx of cos x plus b. Dy by dx of cos x plus b is sin x plus b. So, this is dy by dx. Oh, not dy by dx. We don't need it. We have already derived it. So, it is sin of x plus b. Right? So, y double dash will be this. Now, I want to prove what is y plus y double dash. Y is a sin x plus b. Y double dash is minus a sin x plus b. Now, we can clearly see this and this get cancelled. They are same things. This is 0. So, left hand side becomes equal to right hand side. LHS becomes RHS. Therefore, this is a general solution of this differential equation. I am just telling you the basics. This is not how the question will be asked. I am just teaching you the basics right now. I will tell you how the questions will be asked. Now, what do we understand by particular solution? Why am I teaching this? Because in the exam, in the question paper, it will be written. Find general solution, find particular solution. So, you should know now what is general, what is particular. Okay, chalo. Now, same to same equation, let's say that my differential equation is y plus y double dash equals to 0. My general solution is a into sine of x plus b. Okay, my general solution is a into sine of x plus b is equal to y. Now, what is particular solution? Particular solution is basically if you have any constant, that constant should have some value. So, if I say that let a is 2, okay, let b is pi by 2. Now, this becomes a particular solution. What I have done here, I have given a as 2, b as pi by 2. So, I am giving value to the constant. So, if I give some value to the constant, it becomes particular solution. Now, you will say, ma'am, can we give value on our own? So, can I write 2, pi by 2, pi by 4, anything as my wish? No. I will tell you how you can find out the value of that particular solution. Okay. So, moving on, let's do some questions. But before that, one very important shortcut trick and tip here for you, which is asked in the question paper. If they ask you that what is the order of the differential equation given the arbitrary constants. Now, what are arbitrary constants? This a and b are called as arbitrary constants. So, if the general solution is a into sine of x plus b. Now, here there are two constants. One constant second constant. So if they ask you what is the order of this equation, it will be 2 because 2 constants. So remember, order of differential equation is equal to number of constants in the equation. Okay. Now this was general solution. What about particular solution? Particular solution does not have a constant. A will be 2, B will be pi by 2. They will have some value. There is no arbitrary constant. So we will say that the number of arbitrary constants are basically 0 in that equation. Okay. Moving on. Verify that this function is a solution of this differential equation. Y double dash minus y dash is equal to 0. For this, what you will do, you know what is y. Can you find out y dash? Y dash will be dy by dx of e to the power x plus dy by dx of 1. This is e to the power x and this is 0. Any constant differentiation is 0. So y dash is e to the power x. Similarly, can you find out y double dash? Y double dash will be again dy by dx of e to the power x, which is e to the power x. Now the question is asking, just put the values here. Y double dash minus y dash is equal to 0. So what is y double dash? E to the power x. What is y dash? E to the power x. Is it 0? Yes. LHS equals to RHS. Proved. Okay. Next question. Find the number of arbitrary constants in the general solution for the differential equation having fourth order. In the question they are telling you the order is 4. They are asking you how many constants will be there. Just now I told you the formula. It will be 4 only because the order and the number of constants are same. This type of question is asked, so please note down this formula. Okay, you'll remember. Now let's solve some methods for finding out solution of first order and first degree differential equation. Now till now I have taught you what is a general solution, what is a particular solution, but I have not told you how to find out general and particular solution. I have a differential equation, but how will I find out the solution? That's what we are going to learn. There are 3 methods: variable separation, homogeneous and linear differential equation. In your exam, in the past few years, all these methods have been asked. Each and every method have been asked in the question paper. So you should know all the methods. Okay, let's learn them one by one. First is variable separation method. Now what do we understand by that? It says that if dy by dx is f of x upon g of y. Now what is f of x, g of y? F of x is basically a function of x. G of y is a function of y. So if you want to find out solution, what you will do? Put y together, x together. So g of y into dy, f of x into dx. And now you integrate both the sides. You integrate function of y with respect to dy. You integrate function of x with respect to dx. You will get your solution. Okay. Now integration is something which is an altogether a new different chapter. We will do that also. But I hope you all know integration because a lot of integration concept is going to be used in this chapter. Let's solve a question to understand. There is a differential equation. Solve it by variable separation method. So my equation is x dy by dx is 6 into y. So x one side, y one side. So let us do that. Dy upon 6y is equal to dx upon x. Integrate. What do you get? So when you integrate, integration of 1 upon y is log y. So you will get here 1 by 6 log y is equal to log x, because integration of 1 upon x is log x, plus some constant. Since we are finding out general solution, general solution should have a constant. So we'll just write here plus C, any constant, C, A, B, whatever you want, just write a constant, okay. So from here we will get, that's your solution. So this is your answer, nothing else. This is your final answer, you can stop here, okay. So this is variable separation method. Now that was very easy. We found out general solution. They can ask you in the question, find particular solution. So again, let's see how to find particular solution. First of all, whenever you want to find out particular solution, first you have to find out general solution. Okay, chalo. Let's apply variable separation method. dy by dx is equal to 1 plus x plus y plus xy. Separate x and y. Try to separate them. dy by dx is 1 plus x plus y common 1 plus x. From this, if I take out y common, I'll get 1 plus x. Again, I'll take out 1 plus x common. So this is 1 plus x common. What is remaining? 1 plus y is remaining. Now, we'll simply distribute it. So, it becomes dy upon 1 plus y is equal to 1 plus x into dx. Okay, I am putting this, sorry, I am bringing dx on this side, 1 plus y on this side. है ना? Now integrate. What do you get? Again, 1 upon y is log y. So this will become log of 1 plus y is equal to 1. Integration of 1 is x. Integration of x is x square. And the power increases. Okay. So integration of 1 is x. Integration of x is x square by 2. So whatever goes the power also goes in the denominator. So plus C, some constant should be added in the general solution. Now you have to find out the particular solution. How to find out particular solution? Put y is equal to 0, x is equal to 1. So log 1 plus 0 is equal to 1 plus 1 by 2 plus C. Now this is log 1 is equal to 3 by 2 plus C. What is log 1? Log 1 is 0. So 0 is equal to 3 by 2 plus C. This implies that C is equal to minus 3 by 2. So you have got C as minus 3 by 2. Just put it over here and you have particular solution. Okay. So the particular solution of this equation will be x plus x square by 2 plus minus 3 by 2. So just put C as minus 3 by 2, you will get the particular solution. Okay, understood everybody how we are applying variable separation. Next method is homogeneous differential equation. Now, there will be some questions where you cannot separate x and y. Obviously, it's not always possible to separate x and separate y. Sometimes they'll be mixed together. So for those type of equations, you have homogeneous or linear differential equation. How to identify that it is a homogeneous differential equation? First, your equation should be of the form dy by dx, a function of x and y, another function of x and y in the denominator. Okay. Now, if you have such equation, try to analyze, is the degree of numerator and denominator same? Example, if I write here as 2 times of x square plus 4xy minus y square upon x square minus y square. You check power. You just check power of all the term. Power 2, 1 plus 1, 2, 2, 2, 2. So here all power 2. Here also all power 2. So if you have a differential equation like this, where everybody is having same power, then you call it as homogeneous differential equation. So f of xy and g of xy have same powers. Then homogeneous. It is homogeneous differential equation. Okay. Now, what is homogeneous? We understood. But how to solve homogeneous differential equation? First of all, your equation will be of some form. You have to convert your equation in this form. How come? Let's take the same example. Suppose my equation is dy by dx is equal to 2x square minus 4xy minus y square upon x square minus y square. Now what you will do is just divide the numerator and the denominator with same power x square. For example, if power is 2, just divide it by x to the power 2, x to the power 2. Divide and check, what will you get? So it will be 2x square upon x square will be 2. 4xy upon x square, 4xy upon x square will be x cancel, it will be 4y by x. So it will be 4 into y by x minus y by x whole square, because y square x square, upon 1 minus y by x whole square. Now if you observe here, now your differential equation is of the form function of y by x, function of y by x, function of y by x, function of y by x. So you have converted your entire equation in the form of a function of y by x. Clear? Now what will you do? Now you will simply put let y upon x is equal to t. T is again some arbitrary variable we are taking. Now if y by x is t, this implies that y is equal to x into t. Let us differentiate it with d by dx and d by dx. What will you get? You will get dy by dx is equal to, when you differentiate this side, product rule will be applied. So it will be dx by dx plus dt by dx. Right? So you are getting here dy by dx will be 1 plus dt by dx. Right? So, oh sorry, my bad. T multiplied here, x multiplied here. That is the product rule basically. So you will get, let me write it again. So when we apply the product rule, you get differentiation of x multiplied with t, differentiation of t multiplied with x. So here you get dx cancel, you get t plus x into dt by dx. So why am I doing all this? Because this is very important. Dy by dx will be put here. Here we have to put dy by dx to convert this into a t equation. We need an equation in t. We don't need an equation in y by x. So now your equation will become what? So now your equation will become, so after you have dy by dx, t x plus dt by dx, so this equation can be written as what? I don't have space here, so I'm just going to write it over here. So now your equation becomes dy by dx is t plus x dt by dx is equal to 2 minus 4t minus t square upon 1 minus t square. So this equation becomes this, an equation in the t form. Okay, and after that we will do integration and we will find general solution. Okay, so this was all the basics. Now let's do some questions. Now similarly, what are non-homogeneous equation? Equation which does not have same power. For example, if your equation is dy by dx is equal to 4x square minus xy minus y upon x square minus y square. Power 2, because 1 plus 1 is 2, power 1. Now this power 1 is basically non-homogeneous because everybody else is having power 2 but it is not having power 2. So this is non-homogeneous. We cannot solve it with this method. Okay. Now let's solve one question of homogeneous differential equation. First, x into cos y by x dy by dx is y into cos y by x plus x. Let me write it again. Cos y by x dx is equal to y cos y by x plus x. Now let me convert it into the form of y by x everywhere. So what I can do is, I will bring these two terms on the left hand side. Okay, so we have here, oh, why have I written dx? This is dy by dx. So it will be dy by dx is equal to y into cos y by x upon x into cos y by x plus x upon x into cos y by x. And I am just bringing this to the right hand side. So this gets cancelled, this gets cancelled. We have dy by dx is equal to y by x plus 1 upon cos x is sec x. So sec y by x. This is my equation now. So my equation is dy by dx is equal to y by x plus sec of y by x. This is my equation. Now let me just put y by x as t. So if I put y by x as t, dy by dx becomes what? Remember, we have solved it. Dy by dx becomes t plus x dt by dx. Put it over there. So my equation will become t plus x dt by dx is equal to y by x is t, sec y by x is sec t. So here t cancel, and I have x into dt by dx is equal to sec of t. Now bring t, variable separation will be used. T one side, x one side. Separate the variables. What will you get? So when we separate the variables, we get dt upon sec t is equal to dx upon x. Now just integration. So 1 upon sec t is basically cos t. So cos t, integration of cos t dt is equal to log x plus c, because integration of 1 by x is log x. Now cos t integration is sin t. So this will become sin t is log x plus c. This is our answer. So our answer is sin t is log x plus c. But wait, you cannot write this as your final answer. You have to put here y by x in place of t. So now your equation becomes sin y by x is equal to log x plus c. So this is your final answer. Okay. Chalo. Yeah. Last but not the least is linear differential equation. Now what is linear equation? Any equation which is in the standard form. What is the standard form? So any equation which is in the form of dy by dx plus any function of x multiplied with y is equal to any function of x. If you see any equation in this form, then it will be solved by linear differential equation method. Okay. So if dy by dx plus p of y is equal to q, then it is a linear differential equation. How do we solve a linear differential equation? This is the formula. Dy by dx plus p of y is equal to q will be y to the into e to the power integration of p dot dx equals to integration of q dot e to the power p dot dx. Now I know you are not able to understand anything from this formula, so let me break it down for you. First of all, if you have an equation in the form of dy by dx plus any function of x. Now what can be any function of x? It can be x, it can be sin x, it can be x square, it can be log x. Any function of x is fine. Okay. So dy by dx plus px into y is equal to any function of x, sec x, cos x, x square by 2, anything, any function of x. If your equation is in this form, step number 1 is to find out integrating factor. This is asked in questions, many times in the previous year question paper. It is asked, what is the integrating factor? Integrating factor is e to the power of integration of this px function with respect to dx. This is called as integrating factor. Now, what is the solution of this equation? Solution of this equation is y into integrating factor is equal to integration of q function multiplied with integrating factor with respect to dx. This is your solution. Let us do one example and you will understand everything. Okay. First, is this in standard form? No. Dy by dx should not have anything multiplied to it. What is the standard form? Dy by dx plus p of x into y is equal to q of x. There should be nothing with dy by dx. So what we can do is divide by x, divide by x, divide by x. Divide the entire equation by x, right? We can do that. So here we will just divide the entire equation by x. So we have dy by dx plus 2 by x into y is equal to x, because x square by x is x. Now it is in standard form. Yes. This implies that p of x is 2 by x and q of x is x. है ना? What is p? 2 by x. What is q? X. What is your integrating factor? Integrating factor is e to the power of integration of p function with respect to x. So e to the power integration of 2 by x dx. What is the integration of 2 by x? It will be 2 times of log x. So this is equal to e to the power 2 times of log x. Now remember, if you have anything written in front of log x, it directly goes to the power of x. So this will be basically, let me write it here. It will be e to the power log of x square. Now, you know log base e and base e gets cancelled. So this will get cancelled. It is equal to x square. So my integration factor is x square. What are they asking you in the question? Find the integrating factor. This is my integrating factor. That is your answer. Done. Alright. So we have completed all the topics. Let's do all the PYQs quickly and let's have an idea of what type of questions will come in your exam. After that, I will also show you the mind map and formula cheat sheet of the entire chapter. Okay. Question number 1 on your screen. Find the order of this differential equation. What is order? Highest order derivative. So this is D3, D2, D1. What is the highest order derivative? D3. So your answer is 3. So the order of differential equation is 3. Simple. Next, find the solution of this differential equation. Which method we will use? Variable separation, homogeneous or linear? Just look at the question. This is dy by dx plus y into px is equal to qx. So this is linear differential equation. Directly we can see it is a linear differential equation, right? So how can we solve it? We'll solve it like this. First, integration factor will be e to the power integration of tan x dx. Because what is px? Px is tan x. So we'll integrate tan x. Now, integration of tan x is what? Do you know? Integration of tan x is log of sec x. Okay. Now, e and log always get cancelled. So, integration factor is equal to sec x. We have integration factor. Now, how to find solution? Solution is basically y into integration factor is equal to integration of qx into integration factor with respect to dx. Now this is qx and integration factor is sec of x. So our answer is sec x into y is equal to integration of sec x into sec x dx. Okay. Now sec x into y is integration of secant square x with respect to dx. What is the integration of secant square x? It is tan x. Okay. So this is y into sec x is equal to tan x plus c. Don't forget the constant. Now look at the options. Option A is the right answer. Y into sec x is equal to tan x. Oh, sorry. Plus c will not be there because they have given y0 is 0. So basically when you put the value of x and y as 0, c will also be 0. So therefore c will not be there and this is your answer. Okay, this is how we solve linear differential equation. Clear? Next question. Find the general solution of this equation. Which method? Variable separation, homogeneous or linear differential equation? This is homogeneous. How come? See, power 1, power 1, power 1, power 1. All are having same power. So, I will write this as dy by dx is equal to 2 times of x divided by x, y divided by x upon x divided by x plus 2 times of y divided by x. So, I have dy by dx is equal to 2 minus y by x upon 1 plus 2y by x. Now, what I will do? I will put y by x is equal to t. Therefore, dy by dx will be t plus x dt by dx. Just memorize this. Just memorize this. Don't need to derive it always. You will not have that much time. Just memorize this. Okay. Now put everything in the formula. So dy by dx, our equation is dy by dx is equal to 2 minus y by x upon 1 plus 2y by x. Put y by x as t. So you get t plus x dt by dx is equal to 2 minus t upon 1 plus 2t. Now bring this t on this side, variable separation. So x into dt by dx is equal to 2 minus t upon 1 plus 2t minus t. Take out LCM, you will get 2 minus t minus t minus 2t square upon 1 plus 2t. So you have x into dt by dx is equal to 2 minus 2t minus 2t square upon 1 plus 2t. Just separate t and x. So you get 1 plus 2t upon 2 minus 2t minus 2t square is equal to dx upon x. Integrate it with respect to dt, with respect to dx. Now, before integration, we can do some things here. What is that? First of all, from the denominator, I can take out minus 2 as common. So, it will become 2t plus 1 upon 2 we are taking out 2 as common, right? So, it will be t square plus t minus 1. If I take out minus 2 as common, this will be dx upon x. So, this is equal to what? I am bringing minus 2 on this side. This is multiplied with minus 2. So, I am just moving it to the other side. So, this is integration of 2t plus 1 upon t square plus t minus 1 with respect to dt is equal to minus 2 into integration of dx upon x. This is log of t square plus t minus 1. This is log of x plus constant. Okay. Now this minus 2 can go to the power of x. So let us put it in the power of x. So this will become log of t square plus t minus 1 and log of x to the power minus 2. Minus 2 is going to the power here. So x to the power minus 2. Now I'll bring log on this side. So it will become log of t square plus t minus 1 divided by log of x to the power minus 2. Not divided by, it will be subtracted by, sorry. Minus log of x to the power minus 2 is equal to constant. So here we have, basically, when you have log x minus log y, you can write it as log of x divided by y. Okay, so it will become log of t square minus plus t minus 1 upon x square or you can do is just make this as positive plus x square. So you'll just multiply it with x square is equal to constant. Now let us put t as y by x back again. So you get log of t square is y square by x square into x square plus y by x into x square minus x square is equal to, we can write the constant as log c. Any constant is any constant. Log c sin c is just a constant. Now just simplify. X square cancel, x and power cancel. So log cancel. You have y square plus xy minus x square is equal to some constant c. Now which option is matching this option? So we can write this as x square minus y square minus xy is equal to minus c. If I change the sign, now option A and this is absolutely same because minus c is nothing but c. See, constant is anything. You can change the constant to log c, minus c, c square, whatever you wish. It does not matter. It's just a constant. So this is my option A, matching. That is my answer. It was a very lengthy question. I don't know how can they give it for such exams, but they have given it. So you have to prepare for it. Okay, next question is find the order and degree of this differential equation. Again, we can see that it is a fraction form, so we have to convert it into whole number. So let's simplify. D square y by dx square will be equal to minus of square root of x square plus dy by dx whole to the power 3 by 2. Now squaring both the sides. D square y by dx square whole square is equal to square root cancel x square plus dy by dx to the power of 3 by 2. Now again, still it is a fraction, we have to convert it as a whole number. So again what I will do, again square, power 2. So I get d square y by dx square whole to the power 4 is equal to x square plus dy by dx to the power 3 by 2 whole square. Now I know that after doing whole square the power will get cancelled, so it will become a whole number. Now I don't want to find out power of dy by dx. That is not of any concern. My concern was power of d square y by dx square. So now I know order is 2, degrees 4. So order is 2, degrees 4. Okay. Next question. The general solution of this differential equation will be dash. X into y dash plus y is equal to x square. This is again linear differential equation. Divide by x, divide by x, divide by x. What will you get? You get y dash is equal to y dash plus y by x is equal to x. Here integrating factor is e to the power integration of 1 by x. because px is 1 by x. So integrating factor is e to the power log x. So log x and e gets cancelled. Integrating factor is x. Simple. So my solution will be, solution is y into integrating factor is equal to integration of integrating factor into q of x dx. So y into x is equal to qx is x, remember? So integration of x into x dx. So this is xy is equal to integration of x square with respect to dx. What is integration of x square? X cube by 3. So we have xy is equal to x cube by 3 and plus c, some constant. Now let's see which option is matching this. So we have, here in the whole equation, I can cancel x and power of x. So I'll get y is equal to x square by 3 plus c. So my answer is y is equal to x square by 3 plus c by x. By dividing whole equation by x, I am getting this as solution. Okay, next question. Find the integrating factor of this differential equation. Super simple. Let's do it quickly. So 3xy dash minus y is equal to 1 plus log x. So just divided by 3x, divided by 3x, divided by 3x. So 3x cancel. Y dash minus 1 upon 3x into y is equal to 1 plus log x by 3x. So we don't have space. Let's do. Integration factor is e. Integration factor is e to the power of integration of minus 1 by 3x with respect to dx. So, integration, oh sorry, not minus 1 by x, 1 by x. Now, integration of 1 by x is log x. So, this is e to the power minus 1 by 3 log x. Now, I have told you anything written in front of log x goes to the power of x. So, this will become what? This will become x, integration factor will become e to the power of log of x to the power minus 1 by 3. Minus 1 by 3 will go to the power of x. Now log and e cancelled, integration factor is x to the power minus 1 by 3. This is your answer. Okay. Last question. Elimination of these arbitrary constants will lead to the following differential equation. You want to eliminate these constants. So you have to find the derivative. So first of all, y dash will be, derive this, differentiation of 1 by x is, differentiation of 1 by x is minus 1 by x square into a plus differentiation of b is 0. So we have 0, yani we have nothing. Okay. Again, double differentiation of this will be minus of minus 1 by x cube into a. So minus minus cancel, this will be a upon x cube. Simple. Now let's put the value of a over here. So this implies that a is equal to minus x square y dash. Let's put this over here. So y double dash is minus x square y dash upon x cube. Square and cube cancelled. So we have y double dash is minus y dash upon x. So if we simplify it, we get x into y double dash is equal to minus y dash, right? So this will be x into y double dash plus y dash is equal to 0. So this is our answer. X into y double dash plus, oh, we have missed a 2 somewhere. Let's see. Oh, I am so sorry. So when we do the differentiation, we also have 2, right? So when we are differentiating x to the power minus 2, it will be 2. Here 2 will come. 2 will come. 2 will come. Again 2 will come. And again 2 will come. So our answer will be x into d square y by dx square plus 2 times of dy by dx is equal to 0. That is option A. Right answer. Alright people, so I hope for now your differential equation chapter is sorted. You will be asked order of the equation, degree of the equation, and general and particular solution. There are 3 methods for doing it: variable separation, homogeneous, and linear equation. Alright, so differential equation definition is not of much use for you, but order and degree is very important. Order is the highest order derivative. Degree is the power of the highest order derivative in whole number, not in fractional form. Similarly, solution of differential equation can be general solution or particular solution. General solution will have arbitrary constants. Particular solution will not have arbitrary constant. Remember, order of the equation is equal to number of arbitrary constants. Arbitrary constants means constants which do not have any value. Next, we have learned linear differential equation. Any equation in this standard form is linear differential equation, and for this you will need the integrating factor. Variable separation is if you can separate y and x, you can integrate them separately and get your solution. Homogeneous is if the power of all the terms in the numerator and denominator is same, then you can solve it by homogeneous differential equation. Alright guys, so that was all in the chapter of differential equations. Hope you enjoyed today's lecture. If you want to keep preparing for Keam exam 2023, stay tuned on this channel. Subscribe to this channel because you are going to get daily videos on physics, chemistry and maths. All the chapters with all the previous year questions solved for you, practiced for you with shortcut tips and tricks and formula cheat sheet and mind maps as well. So do subscribe, and if you enjoyed today's lecture, do hit the like button. Let me know in the comment section what type of chapters you want next. Thank you for joining today. Take care. Bye-bye.